Okay, so this is the notes for 2.2. We first need to do a little bit of vocabulary, but mostly I'm going to give this stuff to you, showing you algebraically, and you can always put it into your own words. So if I want the vertex form of a function, it's going to be a times x minus h squared plus k. And that vertex is always hk. So the x, we always do the opposite sign because of that minus h, and then k is the y value. So that gives us the x and y of our vertex. The axis of symmetry is always a vertical line at the x. That's where it's kind of reflecting, it's mirrored over. So it's an equation of x equals whatever that h is. And then if I give you a function in standard form, that looks like this. Ax squared plus bx plus c. And to find our vertex with that one, we actually need to, so this gives me this vertex. To get the vertex here, I'll do a negative b over 2a. And to get the y value, I plug in whatever the x is here and get my y value. So it's f of negative b over 2a. So I have to find x first, and then I can get my vertex. The minimum value, now I'm just going to refer to my vertex as hk, okay? So the minimum is the y value if it's a positive equation. It's the k, it's the y value. Okay, but it has a minimum because we know a positive equation has a vertex at the bottom. It doesn't keep going down, so it's a minimum, okay, because it then just goes up. We know a maximum is when it is a negative equation, and it will be that y value, which is k, because it looks like an upside down U. The vertex is now at the top, so it has a maximum. Now the intercept form of a function looks like this. A times x minus p times x minus q. P and q are the x-intercepts. If you notice, all three of these forms have an a in them. Those xy table numbers, the 1, 1, 2, 4, 3, 9 that I told you to memorize, that's the number that you multiply the y values by. So this gives you those properties you need to remember of a standard form. It's in your notes. I'm going to use these properties as we go, and that will kind of help explain them. Maximum min values of standard form. Then it gives you the intercept form, but we're going to cover this the second day of these notes. I'll go ahead and cover it in the second video, but it will be day 2 of 2.2. All right. So now if we go to these examples. So if we have, this first one's in vertex form, which we've been doing. We know that I'm going to go right 1 and up 3. Well, that gives me my vertex. 1, 3. That's why this is called vertex form. You might also hear it called graphing form. But I can put that point on here. Over 1, up 3. You were to memorize the points. 1, 1, 2, 4, 3, 9. I take my a and I multiply that y value times that number. So this became a negative 2, negative 8, negative 18. And it does want you to label your vertex and your axis of symmetry. So this vertex is, we said 1, 3. Here's my axis, goes through that vertex. So that is the line of x equaling 1. And then I can plot these points and graph. So I go right 1, down 2, and I reflect it over that axis. I go right 2, down 8, and that's the only other one that's going to fit. Nothing else fits. It keeps going. This one doesn't fit on my graph. So I can see that this one has a max, and we did say it would have a max when it's negative. So it's a max of, and that y value is 3. The domain are all the possible x values, so it's all real numbers because it's going left and right forever, just kind of slowly. And the range is y is less than or equal to 3. It does not go above y being 3. Now, increasing and decreasing, that is the x values leading up to and away. It's going to be doing one thing or another. So if I cover up the left side, so I stop at my axis of symmetry, and just like a line, see how this is going up, which would mean it's increasing. Kind of if it was a line, it'd have a positive slope. So reading it like a book from left to right, this is increasing until it gets to my axis or to my vertex. So it's increasing when x is less than 1, okay, because that's what this is. This is all x is less than 1, because then it hits my axis, which is at 1. And then after 1, it's going down, so it's decreasing. So when x is greater than 1 is where it's decreasing. All right, so now you have the standard form here that we're going to graph. So we need to first find our vertex. I still need all of these things. I need the vertex, I need the axis of symmetry, if it's a max, min, domain range, increase, decrease, all of that. But to find this vertex, it's going to be a point like that. And I know that this is a negative b over 2a, and this is f of negative b over 2a. And I'll explain that here in just a second. So, negative b, remember the number in front, this is a, number in front is b, this is c. Okay, the x's are not included. Now, if there was not a x, then there is no b. But you will always have an x squared, and if a number is not in front of it, remember the number is 1. But if there's not an x squared, you would have a line. So that for a quadratic, you will always have an x squared. You might not have a b or a c, and that just means those are 0. But a will always be a number, because otherwise you don't have quadratic. All right. So if I'm trying to find x, it's negative b over 2a. So negative, and b in this case is 2, over 2, and a in this case is 1. Okay, so my x is a negative 1. So if I'm writing my vertex, I know that's a negative 1. I still don't know the y. So to find the y, I'm going to plug it in. I'm going to find f of x, f at negative 1 instead of x. So everywhere I have an x, I'm going to plug in a negative 1. And when I plug things in, I always put them in parentheses. And then when I put them in my calculator, I do the same thing. So you should get in the habit of doing that so you don't accidentally mess up a negative of the equation or a negative that you're plugging in. And in this case, you should get that y is 0. Okay? So if I plot that point at negative 1, 0, and I label it, and I draw my axis through that point, this axis is at x equals negative 1. If I graph it, those points to memorize, 1, 1, 2, 4, 3, 9. There is no multiplier because it's 1 in front of there. So I go right 1, up 1, and mirror it. Right 2, up 4, and mirror it. And the other one doesn't fit, so I'm just going to, make sure I did that right. It was looking a little off to me, but there we go. So I know this has a minimum, and that minimum is when y is 0. Its domain is all real numbers, and its range is y is greater than or equal to 0. And then we need the increasing and the decrease. Okay, so I do one side at a time. So if I cover up the right side, when x is less than negative 1, it's going down from left to right. So that's decreasing. So x is less than negative 1. And then if I cover it, when x is greater than negative 1, it's increasing. It's going up. So x is greater than negative 1 is my increase. All right. Now down here we have another standard form. So I'm going to need my vertex, which means I need negative b over 2a. That's how I find x. So in this case, I have a negative. My b is negative 3 over 2 times 3 over 2. Now, if you are plugging this into your calculator, you need to add in an additional parenthesis here. Okay? So that way the negatives end up where it should be. And then this, make sure it's dividing by everything and not just one thing. But here I can kind of cancel those 2's out, and I have a negative times negative makes positive. I have 3 over 3. You should get x is 1, even if you plug that into your calculator. So if I want y, I'm going to plug in 1. So I have 3 halves times 1 squared minus 3 times 1 minus 1. So in this case, y is going to equal a negative 2.5. So I have 1 negative 2.5, and I graph that. Oh, no, it'd be right here. I'm sorry. Ignore that. So this is 1 negative 2.5. My axis is when x is 1. Okay, now if I graph this, the points to remember were 1, 1, 2, 4, 3, 9. And I do have an a in this case. It's 3 over 2. So I'm taking that y and I'm multiplying it by 3 over 2. So, and I write them as decimals. I find decimals easier to graph. So this becomes a 1.5, this becomes a 6, and this becomes a 13.5. So from my vertex, if I start to plot these points, I go right 1, up 1.5. I go right 2, up 6. Make sure I don't skip a line there. And then the last one's not going to graph. Make sure you are making this a curve. It does not come to a point at that vertex. And then you now can say, well, it's a minimum of negative 2.5. The domain is all real numbers. The range is y is greater than or equal to negative 2.5. If I cover it up, it's decreasing when x is less than 1, and it's increasing when x is greater than 1.